in offshore geotechnics in 2025, June 2025. Thank you for your attention and sorry for the delay.
Thank you. Thank you very much. Do we have a very quick comment?
No, very clear. Thank you.
Then we can move. Thank you, Luc. We can move forward. Stanislav Lenart is the next one from the University of Maribor. This one?
Yes. Thank you. So without a disclaimer, this is going to be a very short presentation. Explaining just some challenge.
The timer anyhow.
Okay, no problem. I can also try to be long. Yeah. So it's just a short presentation of some challenges we are facing within Slovenia regarding the, I would say, maritime problems, because offshore geotechnic in Slovenia, actually, it's not present. Due to some environmental issues, constraints, I think, yeah, there is nothing happening on this side. Even wind turbines are not very popular. I heard that argument is that birds are in danger, so I think we have only few wind turbines in Slovenia, but there are some problems with maritime. So Slovenia has only a little bit more than 40 kilometers of sea coast, but this coast is at the north of Adriatic, so it's a part where actually Mediterranean Sea comes most closer to Central Europe. So Port of Koper is a major harbor for Central Europe. I think Austria, Hungary, Czech Republic, Slovakia, even south of Germany, they're all using this port as their entrance to the Far East. And yeah, so the problem is that the coast, so the sea depth in Adriatic is rather is not very deep, and so I think in Port of Koper we have approximately 15 meters or something like that. So with bigger ships, there's a major problem how those ships could enter the port. And last years we are facing with a challenge that all the time the entrance to the port has to be deeper. So deepening of this seabed costs a lot of material. As it's written here, approximately 500,000 cubic meters of material is dredged every year from the seabed, and it has to be deposited somewhere. Here on the photo you can see the side view of Port of Koper, and there on the right side there is a place where they deposit those sediments at the moment. So it's not a lot of space, you can, like everywhere, and some suitable solutions are needed what to do with this dredged soil. So few problems which at least in Port of Koper are facing with, and where we were a little bit involved in trying to find solutions. First 2 points are partly solved, while the other two are still in progress. So The first problem is that this sediment, of course, as explained previously, I think at least in 2 presentations, material is very wet, too much water, and traditional approach has been to pump up this material and deposit it in some lagoons, and it took a lot of time. So we try to do something with this. Then we have ideas to use these sediments in earthworks. Then those places where the sediments were deposited in past are very difficult to be used for some kind of construction. So very soft ground and discussion how to stabilize this ground. And the third thing, can we manufacture something out of those sediments? So the problem which we were discussing for quite a long time, because as I said, traditionally sediments were dredged and placed into lagoons, and it took decades before they at least dry a little bit, but the material was still very soft. And as from Port of Koper, a lot of cars are exported and imported for Europe. They need big areas for parking places, and you cannot park a car on such ground. Even without any structure, the settlements becomes very big. So the first suggestion was try to remove the water before you put sediment into the lagoon. So we tried some attempts with using different kind of flocculants, coagulants, and with some simple lab testing with mixing some different polymers with these dredged sediments. We find out that the time needed for sedimentation of this material can significantly decrease. And what is even more important is that during this coagulation process, small particles stick together, and the biggest advantage is that when they stick together, you can dry them by putting them in, let's say, in some kind of filtration, normally with geotubes. So we fill geotubes with these materials, and quite soon you have, let's say, approximately partly dry material, far away from dry, but it's not so wet anymore. So then the problem which we faced, at least from the environmental perspective and further on also with civil engineers, what will happen with this material if we use this kind of additives, coagulants or flocculants? Will the behavior of material change, mechanical properties, and the rest? So we did some deeper analysis, and also if you see those SEM photos from microscope, the structure does not seem to change very much. Either we use some flocculants or not. Probably the reason is that with adding this kind of polymers, this is just a temporary change. So the particles stick together for some time, and so after it settled down, if we load it, this structure seems damaged immediately. It crashed, and we have the same material as previously. This it can be proved by the other tests. So yeah, Atterberg plastic limits did not change very much. Slightly, but in general, we still deal with the same material. Water permeability, we can see at the very small load, the water permeability is, let's say, significantly higher. but as long immediately when you load this material, the structure collapses and permeability becomes the same as from natural material. And unfortunately, also stiffness did not change. So we would prefer if it would, but unfortunately, this is not really treatment which would be helpful for further use of these materials. So next step was, can we use this material for simple earthworks? In Port of Koper, they made several test fields, mixing this material also with lime, with cement, with different kinds of stabilizations. But at the end, always we find out if material is far away from optimum moisture content, then you didn't do anything. So we have to dry material first to a proper moisture, and then it can be used for earthworks. And actually, it's quite material with quite good quality if it's dried enough. So this approach was not something what would satisfy the port administration. So now we are talking with them about two other possible solutions. So they need to, instead of replacing material from lagoons and trying to stabilize it somewhere or use it somewhere, we are talking about deep soil stabilization. And because nowadays it's good if we suggest something new, so not only traditional techniques, we suggest to use some new kind of binders like alkali activators. So it's not really new, but it's very popular in scientific community nowadays. So at the moment we are doing some research on using of fly ash, slag, and this kind of material. So to stabilize those areas where the sediments were placed for decades. And the other possible solution so what to do with this material is also to use it directly for some kind of manufacturing process. And the first idea has been, because this is actually clay material and very nice clay, homogeneous, we thought, why not make bricks out of it? The problem is that if you have salt in material, then there are big problems with firing those bricks, corrosion and everything. So suggest not to do that. But anyway, the next approach is not to fire those bricks, but just dry them in not on sun like in Africa or some other parts of the world, but one of the companies which produce bricks realized that they can also use this heat from conventional producing line. They can use some of this heat just for normal drying of bricks. And at the moment, the approach looks quite good, and hopefully we will also elaborate it in future a little bit more into details. As I think I should be in time, that's just
saving 6 minutes, not
okay.
that much.
Okay. So
Thank you, Stanislav.
Yeah, that's it.
Any comments from the audience? Yes, please.
Just want to comment. I just was wondering if you are aware of the efforts in the Netherlands, EcoShape and similar project on management of sediment. So I will repeat. In the Netherlands, there's a lot on management of rich sediment, and EcoShape is one example where they can well, produce also bricks nowadays, but I don't know if you are aware of that or of these efforts or these projects. No.
Do they produce bricks with firing or without?
I don't know, but I just wanted to hint that they exist. There is a startup doing bricks, and they are using it in some projects already, but using the material as even for strengthening of dikes. These are pilot projects that took place, and EcoShape is a joint industry where Deltares is also part. So there are some maybe ideas around there to look into. Yeah.
Yeah, it's not innovative idea at all. I mean, this kind of approaches were done already elsewhere.
No, it's meant for collaboration. I mean,
yeah,
if
but yes, for collaboration, I think it could be very, very nice to exchange information.
Thank you.
So considering this bridge, Slovenia, the Netherlands, if Slovenia managed to make a presentation on an offshore geotechnics, then the challenges for Ton and the Netherlands to have a